Right, welcome to our lesson on data handling. Today we're going to be looking at discrete and continuous data. We're also going to be looking at qualitative and quantitative data, understanding what these ones mean and differentiating them. Now, once you've collected the data to test your hypothesis, then you need to understand what your data is. Now, the data you collect could be grouped into two groups. Number one, the data could be qualitative or the data could be quantitative. Right? So qualitative or quantitative. Now, qualitative data is basically the data that you can only describe using words. Okay. For example, if I'm talking about the different colors of cars parked in a car park, then I could describe the colors as green, yellow, red, pink. So I can only use words to describe those. Okay. If I'm describing gender, then I can only talk about male, female, girls, or boys. I can only use words to describe qualitative data. Now, with quantitative data, you can only use numbers to describe them. You can only use numbers to describe quantitative data. Quantitative means numbers, basically. Okay. For example, if I want to know how many students are in a class, then I can only use numbers to describe that. I can say there are 20 or 25 or 30. Or if I want to estimate the age of different people in a bus, then I can say that somebody is 20 years old or 30 or 50 or 21. I can again just use numbers on that. So if you're using numbers, then it's quantitative. And if you're using words, then it's basically qualitative. Right. We go to types of quantitative data. Quantitative data, which is data that takes number, can be grouped into two groups. Number one, it could be discrete or it could be continuous. Okay, so both these ones are basically quantitative. Now, with discrete data, the data can only take particular values, especially whole numbers. For example, if I want to know the number of students in a class, then I can only say the other 10, or I could say there are 12, or I could say there are 30. The numbers can only be whole numbers here. So we say they're discrete. Now, discrete data is data that if you're collecting, you have to count to collect discrete data. However, some types of data could be continuous. Now, these continuous data, they could take any value. They could be even decimals. For example, 2.5 centimeters, or I could say 9.2 grams. So continuous data is data that will take any value. They could be fractions, they could be decimals, they could be whole numbers. They're just basically continuous. Now, with continuous data, to collect them, you normally have to measure. For example, if I want to know how heavy somebody is, I have to measure that. And the answer could be something like, say, for example, 70.5 kilograms. Okay. So that would be how heavy that person is. So I have to measure this, and the answer could be even a decimal. So in that case, it's continuous quantitative data, right? So it's quantitative because it's number. It's continuous because it can take any value, including decimals. Now, the number of people in a bus or how old somebody is, if I'm talking about just their ages in terms of years, then I can only use whole numbers. 1 year old, 2 year, 3 year old. In that case, it's as if it's just counting how old the number of years they've spent on Earth. Okay, so having understood that, let's try example 2 now. Example 2 says, state whether the following data is qualitative or is discrete quantitative or continuous quantitative. So let's look at part A. Part A says the hometown of 100 people. Now, the focus is not 100 people. The focus is their hometowns. So if I was going to answer that question, I've got 100 people in front of me, and I'm just interested to know their hometowns. Then I'm going to use words to describe those towns. It could be London, could be Portsmouth. It could be just using words to describe that. Okay. So in that case, the answer is going to be qualitative. Number 2, the weights of the bags of potatoes on sale in a greengrocer. Right. We're talking about the weight here. How do you measure weight? You measure weight in numbers. So that's going to be quantitative to start with. Okay. The next thing, the weights of the bags could take any value. And to find what they are, I have to measure. If that's the case, then the data is going to be continuous. Right. So the weight could be decimals also. And I've got to measure to find what the answer is. Okay. right? So that's what we have here now. Now, I'd like you to pause the video quickly, and we're gonna try question 1 all the way to question A all the way to J. So pause the video and try question A all the way to J. Okay. Right, so with these ones, I'm not gonna go over this. I'm just gonna show you the answer quickly, and if you want to pause the video and then just mark your answer quickly. Okay. So pause the video and then try that. Okay. Right, so hope you marked your work. Now let's look at question 2 quickly. So you're gonna pause the video and try question 2. Pause the video and try question 2. Okay, hope you've tried that. All right, so question 2 says, Gemma thinks there's a link between the average number of chocolate bars eaten each week by pupils in our class and how fast they run 100 meters. So she's thinking that maybe those who have eat a lot of chocolate, they run faster than those who eat less chocolates. Okay, so that's what maybe she's thinking, and she wants to find out that. Now, question A, describe 2 sets of data Gemma should collect to investigate this link. Now, the 2 sets of data would be coming from this information here. She would want to know, on average, how many number of chocolate does each student eat in a week. So that's the first set of information. The number of chocolates on average each child consumes in a week. The other one is how fast they run, right? So the time they take to run 100 meters, that's going to be the next set of information that she needs. Question B, describe suitable methods for collecting the data. The first one, to get to know how many chocolates these kids eat in a week, she will need to ask them. Maybe in a questionnaire, she can design a questionnaire and let them answer how many chocolates on average they eat in a week. Okay, so that's just using questionnaire. In terms of finding how fast they run, she can now do an experiment, get each one of them to run 100 meters, and she can just basically time them using a stopwatch. Okay. Question C, say whether each set of data is qualitative, discrete quantitative, or continuous quantitative. Now, the average number of chocolates, you can only get this by counting. So that's going to be quantitative. Now, the chocolate bars could be 1, 2, 3. We're not talking about how heavy the chocolate is. We're talking about how many the bars are. So that's going to be discrete quantitative. Quantitative because they're numbers, discrete because they can only be either 1, 2, 3. You can only count them to get whole numbers. As for the time taken to do 100 meters, that's going to be what? Again, quantitative, because you're going to be measuring the seconds or the minutes that these students are taking to do 100 meters. Right? Time is continuous because it can be decimals, it can be seconds, it can be minutes, it can be decimals. So that's going to be continuous quantitative. Now, say whether each set of data is primary data or secondary data. Collecting the number of chocolates, the average number of chocolate bars. Again, she's designing a questionnaire and she's giving it out for the students to fill it up. Again, that's going to be primary. In terms of doing the 100 meters, she's going to the field with them. She's timing them. That's going to be, again, primary. But as for the average number of chocolates they eat in a week, she could also collect that secondarily. Maybe if the school has got a record of how many chocolates these students take, then she can just go and to the school and they can just print it out for her. So that could be secondary. But in the way that she's collecting it here is going to be primary because she's going to be doing the questionnaire, she's going to be giving it out, she's going to be collecting back the results. So that's going to be primary. Okay. If you want to pause the video and then just basically mark your work. Right, so hope you've done that. Right, so then I move on to the next slide. So pause the video and then have a go at this one. Right, so hope you've tried this one. So it says, Blair wants to find out what 12 people think about his favorite TV show called The One Discretion is Cambria. So that's her show. That's his show, and he wants to find the opinion of these people about it. Now he first asked 6 people, how much do you like the One Direction is Cumbria? So you ask him that question, and then he notes down their responses. He's writing down every single response. The first person says it is all right, and he writes it down. The second person is brilliant, and he writes it down. He writes a sentence exactly as these people are saying. Okay? Now, he then asks another 6 people the same question and asks them to give their response as a mark of 10. His results are shown below. So the first 6 people, he was asking them to say a sentence in response, and he was just writing down what they're saying. But as for the other people, he was, telling them to take either 2 or 4 or 10 or 8 or 7 or 9. Maybe 10 being that the show is excellent, and maybe 2 means that the show is really bad. Okay, so they were just to take that. So question 1 says, does his first set of results consist of qualitative, discrete quantitative, or continuous quantitative data? These are results described in words. Anything described in words is always qualitative. Okay. Does the second set of results consist of qualitative, discrete quantitative, or continuous quantitative? These are numbers. So first of all, it's going to be quantitative. But again, because they can only either be a 2 or a 4 or a 10 or a 8 or 7 or 9, they can't be decimal numbers. So we now say that they are discrete. Okay, they're discrete. Part B suggests one advantage and one disadvantage of collecting qualitative data instead of quantitative data. Now, if you look at this response here and this response, which one is easier to even think about? Now, to collect this data is going to take a lot of time because first he's going to write every single sentence the person is saying. That's the first thing. So it's going to be expensive to do this in terms of the time, in terms of also resources, because he might need to employ people, to help him get this kind of information. The time is going to be spending writing, printing, and all that. The other thing is that it's quite difficult to analyze this. Now, what does it mean says that it is all right? What does this person mean that the show is all right? And what does this mean that it is brilliant? So the person who says it is all right and the other one says it's brilliant, who likes the show better? Okay. Somebody says I shouldn't like it, but I do. Now, what does that really mean? So when it comes to analyzing this, when it comes to making sense of what people are saying, it becomes very, very difficult to even group them. Whereas here, if somebody takes 10, now this person basically means excellent. He loves the show so much. And if somebody takes a 2, then this person means that he really doesn't like the show. The show is poor as far as concerned. So it is easier to analyze this, but it's much more difficult to analyze this. And again, it takes short time, to collect this data because all the people need to do is to just take it, right? So that saves time. Right. So you're gonna pause the video quickly, and if you just mark your work. Right. So hope you done well on that. So that's gonna be the end of our second video on data handling.